Hi guys, today I am going to show you a machine learning model that is called linear regression model. In the linear regression model, there is two type of linear regression model we can make based on the prediction. First of all is the single variable linear regression model and multiple variable linear regression model. In multiple linear regression model, we estimate the relationship between more than one independent variables and on dependent variables. Here we can see the equation equation y equals to s1 into x1 plus s2 into x2 plus s3 into x3 plus c. Here x1, x2, x3 are the independent variables, and s1, s2, x3 is the slope or coefficient of the respective variables, and c is the constant that is intercept of our line. We can see a third dimension multiple linear regression plot here. Here's the temperature, and here's the right side is the rainfall, and the upper side is the apple production per year. We can make the plot to see how our multiple linear regression model works. Below the chart, here we can see the simple linear regression model. Say we can say that how much money we'll earn in a certain period of time. Here is a certain period of time. That's time is our independent variable, and amount of money we'll earn in a certain at the end of the period of time, it will be our dependent variable. And in another case where multiple regression model works, we gain the certificate, and we have age, and within a certain period of time we'll earn the money, or a person will earn the money. That's where is a three variable. One is his certificate, another his age, and third is the amount of time he will earn the money. And we'll check our inputting our independent variables, and we can predict our dependent variable result. That's how our multiple regression model works. Now I am going to predict the model using the Python and its respective libraries. Now guys, I'm going to import our libraries that's required. First of all, I'd like to import libraries pandas, numpy, and matplotlib. First two is the computational, mathematical computational, and third is the plotting our libraries. I'm importing libraries. Import pandas as pd, and import numpy as np, and import matplotlib pyplot as pd as plot plt plot. Now we run our code and we'll import our data set. We can see our data set as df. We'll use pandas to read our data set. Our data set is the startup data set. We can check our data set where it's here is our data set. Here is our data set. Startup CSV, startup CSV. Guys, wait a minute, it will open. Yes, here is our data set. In our data set, research and development spent, administrative spent, marketing spent, state in 3 state, New York, California and Florida, and respective profit of this startup. Now I'm going to import this data set. We'll check its set. Yes, as our data set. In our data set, here is a characteristics value. One is the characteristic value, there is a state. Now we'll convert this characteristic value to the binary value, binary dummy variables. Now I'm going to convert the value New York, California and Florida to 0 and 1. And we'll input 1, where is the New York, and where is the new node. We will denote it 0. I'm copying the line 3 times. And here's the California. California, New York, California state, California state, and Florida state. Florida state, Florida state, and New York state, New York state. Florida state, and second is our California state. Yes, now we check our data frame. Oh, we make a mistake. State. Oh, yes, we have another mistake happen here. Yes, another mistake. Yes, we can check it. Yes, it's work. Yeah. Now we'll split the total data frame into two variables. One is independent variables and another is dependent variables. Here our dependent variable will be profit and our independent variable will be research and development, administration cost, marketing spent, and our three state, New York state, California state, and Florida state. Now we are splitting the data frame into two parts. In our y, that is dependent variable, we'll take it the profit, and another is our before that we have to draw we have to eliminate our column profit for our data frame to make our independent variable x. We drop out the value. Here is our xs1. In place true. And now we make the data frame column. Oh, we have a mistake here. Now, yes. Now, state is removing here from X. Yeah, sorry. The profit is removing here, and we split the state into three column: New York State, California State, and Florida State. Now we'll train the model. We have already created two variables. One is X and another is Y. To train the model, we have to call libraries. From a scikit-learn model, selection, import, train, test, split. Train, test, Y train, Y test. Train, test, split. X, Y, test, size, free, random state, zero. Now we will import the linear regression model from scikit-learn. Linear model, import linear regression, model, fit, X train, Y train, train. Yes, we have made a mistake. Model. Model. Yes, we have not yet. Oh, we have given mistake. Model. Regression. Yes, our regression model is working. Now we check our intercept and coefficient of the model. Here is our intercept of this model, and we will also check our model constant, model slope. We have already find out our constant. Now we now would like to find our slope of this model. Here is the our model coefficient. Here's the constant. We'll check our two model constant in this separately. Yes. Here is our model slope. Here is our slope. Now we'll make the prediction. Before making prediction, we have to check our head. Model predict here is our 1 2 3 4 5 6 independent variable. We will put 6 independent variable value to predict our dependent variable result. Now we are using on Our marketing spend, we can give it 3 lakh, and our state is Newark, and we will put rest of the field 0. Now we can make the prediction. Yes, here is our predicted value, 72,237, and we'll make another prediction here. And now we can say it's from Florida, the last one. Yes, we can check it. Yes, it's 4,14,129. Here's the profit in our prediction 2. Now we will make another prediction based on our model. Here's the model. Yes, and we can make we can take the value from our above. Yes, we are checking the how much it will deviate, make the deviations from the actual result. Yes, and now it's from state Florida, and we are making the state Florida is 1, and rest of the 2 states is 0. That's it's from the state Florida. Now we run the code. Yes, and we're checking the value. Yes, we have to checking the value. Where is the it is for? Yes, profit 1,66,187, 1,66,000. Yes, it's our predictive result is slightly different from our actual value. Now we will train the model result. Here's y, pretend model predict x train y t here's the train model result. Now I'll plot the result, actual result and our predictive result, to check our model, whether our model is good fit or not. For this we'll call the matplotlib libraries. Y train and Y pre-train. And our X label will be actual profit, and our Y label will be the estimated or predictive profit. Our Y label will be predictive profit. And we have to show the result, the show function, using the show function. Yes, here is our predictive profit and actual profit. We can see our curve is straight line. Here is a pure positive relationship. Now I'm checking the result. I'm checking our model using the test R-square test. I'm call the R-square score from scikit-learn. Matrix, import R-square score. R-score train model Y. Train model Y pre-train. No. Yes, here is our R-square result. R-square result is between 0 and 1. When our square result greater is R-square result will be close to the 1, it will the better better model is suited. And when R-square result is near to the 0, our model is not suited at all. That's in our result it's 0.95155. That's near to 1. That's why we can infer from this result that our model is nearly perfect. That's all from our today's sessions. Thank you everyone. Thank you for watching this multiple linear regression model tutorial. Thank you all.